some key information about the document. The VLM returns the data back, and the agent then goes back to the user and answers like whatever it had to answer. So this is a super common pattern. You could implement this in pretty much like every agentic framework in under 10 minutes today. But there are some big problems with this MVP, and the main thing is that it would require like reparsing the document every time someone is asking the same question. Like you go to the VLM again, and then the VLM answers back, and so on. And there are problems with talking to a VLM a lot of times, latency being one, not being reliable is another. Third, can the VLM like handle a lot of pages and a lot of documents and so on? And people feel comfortable when there are citations, right? And if the agent answers the question, most likely the people on the other side will feel a lot more comfortable if there were citations. And finally, when the agents get some answer wrong, like the people would probably the most likely like give it some feedback, and agent builders are interested in collecting those feedback and correcting the results for subsequent questions and so on. So memory is an interesting thing here, because memory, what it is that it makes an agent stateful. What it allows, in this case, an agent to do would be that the agent would remember the whole document after someone has asked a question about it for the first time. And for future subsequent questions, the agent might not have to like talk to a VLM again and introduce like new form of errors. It might be able to do like on-demand structure generation queries and so on. And finally, for making things faster, the agent might be even like caching answers, collecting feedback, and so on. And this is where we see vector databases and databases become useful. Now, memory is pretty undefined. Like what a memory for an agent is like pretty undefined. You ask 5 people or like 10 different people, like building agents, like everybody has implemented memory in a slightly different way, right? But the main principle is that the key things that people are building when they're introducing some state in an agent is usually some form of like ability to look up information. And when they look up information, they are probably like looking for a lot of accuracy when they're looking information. But in a nutshell, like that is like what memory would mean in this case. Even then, like we would still be like running into some problems. Most likely, like people who are building agents are building agents in an ambitious way, like where they would be wanting to build an agent for the whole company or for a whole team and so on. The question is like, can it handle like thousands of documents or thousands of contracts? The thing that we usually see is that the pipelines and the ingestion systems that people are building like are often brittle. And we see like once people figure out the technology that they want to use for ingesting data, they are then like dealing with a lot of infrastructure problems. You're probably well aware of like workflow systems like step functions, prefetch, and plural. There are like millions of these. Once an AI engineer is starting to like work on the ingestion system or figured out what data they need, they are then going to be spending a lot of time and standing up the infrastructure for workflows. And often in the early days of building an agent, what takes like 5 minutes to do a prototype or an MVP, that might take like weeks or months to like stand something up in production. And the third thing that we see like people complain about or struggle about is that documents, even if like they contain the same information, are laid out in a different way. They express the same information in different ways. A good example is like bank statements. Bank statements from Schwab, JP Morgan, or any other bank, like they look slightly different, even though like they have the same information. So when a developer is testing their agents with some particular document and then they go to production, quickly they find out that the variability of document layouts and the way information is laid out often introduces a lot of error. So what seems like super simple in the beginning, in reality, for an agent that needs to be 99% times reliable, in practice it's hard. Documents have almost like no structure in the real world, right? And so it's a harder problem once people start building. They really start seeing that. So what we have seen work is that whenever like people are building agents, or whenever you are building agents, you want to one, like store all the information that you ingest, and second, not only just like digitize the documents, but store like some kind of like structured information about the documents. So what I mean by structured information about the documents is that in the case of a real estate document, a real estate purchase document, you might want to store the key information that is in the document, laid out in the document across different pages, the most important information. In the case of real estate documents, it would be like the address, the name of the buyers, the name of the sellers, the time it takes to do escrow and so on. If it's a bank statement, you would want the bank balances, the account numbers, and so on. We have seen agentic memory work really well, like when there is a combination of both like structured data and traditional embedding and chunks. And lastly, like to make the queries and the retrieval of the memory very effective, we've seen a hybrid mechanism of querying that works really well. And this is where a database like Qdrant is super useful, because you can combine hybrid search with like filtering of metadata and so on. Like filtering the metadata like reduces the scope, and then like search improves like the accuracy of the information that is coming out of it, and agents usually perform better. And we also see building a knowledge graph is often useful. Maybe like less in the context of a real estate agent, like where data is always like confined to like a family or a person or like a home, but in a complex rich domain like enterprise data, where you're trying to build like an internal knowledge base, building a knowledge graph on top of a database like Qdrant that improves the data that comes out of it. And finally, need a reliable document ingestion API. So this is how I would do this. I would build an agent which is relying not only just lookup of embedding-based information, but also like applying filters to the data, and then finally like reduce the answer to the queries. So where do we help? Where does Tensorlake help in this whole process? We build a document ingestion API where not only like we chunk a document so that it can be easily embedded and inserted into a vector database, but we also offer structured extraction from the same API. What it means is that if you're building a pipeline which is ingesting data and then have to perform embedding, have to perform chunking, and then do structured extraction so that you can add some JSON structured data along with your embeddings, you no longer need like two different APIs or build an entire one. We have a single API that which offers like structured extraction and chunking at the same time. We provide layout error parsing. What it means is that you would get information about the section headers or the table numbers, the figures, or the bounding boxes of where like data has come from, so that this can also be inserted into a database like Qdrant. And so when you're retrieving information out, you can actually know the coordinate of the page from where the information came from. So this is super useful in improving like confidence. And finally, most complex documents have like tables or like forms. And if you don't do a good job in like parsing forms and tables, in my opinion, the document ingestion API is like not good. And often like we see a single document will have like many types of pages. So let's say like you're doing like a claim packet or building an agent like which parcels like claim packets in an insurance company. You are probably looking at like medical records, or looking at like time balances and so on in a single document. You might want to like collect different types of, extract different type of structured data from different type of pages. So we build that ability inside our API where the API can do page classification, and then based on different classes, or it can extract different types of data. So this is the API in a nutshell. Like you provide, it can ingest like PDFs, Word documents, presentation, and so on, and then it can emit structured data and chunks that can then be served into the database. This is a really complex one, and we worked almost a year to get to this place. This is a kind of a document which OCR engine, like from back in the day, would struggle, because OCR engines were traditionally meant for text recognition, and they would then just do like left to right parsing of documents. Whereas like if you're building an agent on a document like this, the agent doesn't really care about only the text, but it also like probably wants some information around the text. And if there is a text and a checkbox, the agent probably wants like some kind of like Boolean value like around that text so that it can make a decision. Same thing with tables. If you have a table, it might want a specific column from that table. So like parsing this form in a way that can be understood by LLMs is like really important. So we spent a lot of time in working on decomposing a document like this into various semantic chunks, and from the semantic chunks like we derive structured data that can easily be understood by agents. And same thing, there are many ways to read a form. And so what we have done is we provided users like with an API so that they can provide like some kind of a JSON-based schema for the entire document, and then what Tensorlake does is conforms that document into the schema that the user has provided. So you could like then ingest like thousands of these forms, and every time like you get the same structured data. Now once you have the same structured data out of like the documents, then you could like insert them really easily, and the filtering logic for the retrieval can always rely on the same structured data being present on all the rows in your database. There are many people like doing document ingestion. So a common thing that people wonder is that what is Tensorlake doing so different here, and why should we pay attention? In my opinion, we do layout understanding the best. The reason why we focus so much on layout understanding is because we saw that there are one-shot models like Gemini and OpenAI and so on. They are also able to do document ingestion. The problem with one-shot models is that as the document becomes more complex and becomes more dense, the risk of hallucinations increase. And this is not really like hard to understand like why that would happen. In a dense document, you're asking the model to generate a lot of data. And as the model generates a lot of data, the risk of hallucinations towards the end starts increasing. So you provide a model with a very complex and dense document, and then you see the reliability of parsing that document decreases. So what we do in Tensorlake is that we take a document and then we chunk it into various semantic stages. We break it down into forms, text, and tables. Now the scope of parsing reduces quite a bit. And after we have reduced the size of fragments that we need to process, the accuracy of parsing increases quite a bit, to the point where we can always say that we can rely on the data that we get out of it. And then again, this is traditionally called like pipeline-based parsing. Pipeline-based parsing has been around for a long time. Pipeline-based parsing usually means the pipeline is first performing layout understanding, and then specialized models are being applied at various stages to parse different components. What we did is that what we saw when we started working on this project is we saw that a lot of the academic data that people are using to build layout understanding models are simply incorrect or not labeled correctly. A lot of times, pictures which look like a table would be classified as forms in an academic data set. And usually, when someone starts to build a layout understanding model, they start with academic data sets. And we saw that the most popular data sets have 30% or 40% incorrect labeled data. Second, in academic data sets, business documents are not present. So like your accord forms, like which are bread and butter of the insurance industry, or like a real estate purchase form, like which we see when you are like buying a house, or your bank statements are not there in most data sets. So what we did out there is we collected a lot of proprietary data set so that like we could have a layer understanding model which works on the data that people actually use in the real world. The second thing we did is we generated a lot of synthetic data. Like checkboxes are extremely hard to parse. So you throw a complex form with like hundreds of checkboxes, reliability goes down quite a bit. So we figured out all these gaps in the models, and then we generated a ton of synthetic data along with like proprietary data that is usually like not found in data sets. We came up with a model like which performs really well, and it doesn't leave anything behind on the page. When it doesn't leave anything behind on the page and the amount of parsing that we have to do is small, the reliability is like generally like a lot higher. Remember I said that we started off as a platform for building unstructured data, like processing unstructured data. Data is usually in a lot of different places, like SharePoint, your Dropbox and so on. People usually ask me, like, do you guys have connectors? Like, do you have connectors to different data sources? We took a different approach to that. Instead of like building data connectors like Fivetran or any other company has done, which we think are really valuable, but there are enough people like doing it, we took a different approach. What we built is we built a workflow engine where a developer can write Python programs and they can connect these Python functions together in a workflow. So what you have is an API which is simply like Python functions, but they can all be connected together and they can be run on a real cluster to describe any sort of workflows, which can run on GPUs and on completely managed infrastructure. So again, like if you're doing vibe coding or if you're like writing some Python program to ingest a lot of data to build an agent, instead of spending hours and hours on like MapReduce, Spark, Hadoop, or whatever, like you now have a platform where you can write distributed workflows which can run on hardware accelerators or like quality model APIs just to that's pretty much it. We have a little demo here. We built a playground so that you can easily like test, drop a document and see like how it looks. We have seen that experimenting with documents becomes really easy. Like if it's easy to see like what kind of information can be extracted out of these documents. You can summarize tables. This is your typical like Pydantic model or JSON schema, and then different parts of like the document gets extracted as JSON. And finally, we know that data is super sensitive, so we made it possible so that the data processing happens completely inside the network of a company if they're super sensitive, if they have super sensitive data. That's pretty much it. So Tensorlake in a nutshell, like we do like reliable and accurate parsing and a single API for structured extraction, text ingestion, and document ingestion. We have a playground that's like free to use. Sign in and drop a document and see how it does. That's it.
Thank you. Shout out Tensorlake, shout out to Penn. Make sure you check it out. I also love your swag. That's a dope shirt, man. Shout out to you. Oh, I left my laptop over there, but I won't need it because to end the night, everyone first, please give a round of applause to Jim Lay from n8n. Jim, can you speak, please?
Yep. Hi, everyone.
Oh,
Hi.
let's see. I need to get the audio on you. So give me 1 second.
Yeah.
All right, Jim, can you speak?
Yeah. How about now?
A bit of an echo. 1 second. Try again.
Yeah. How about now?
Oh, 1 second.
How about now? Assuming you guys can hear me. Get started. Sorry. I can't really hear you guys, so I'm not sure if I'm on, but I can get started. Signal, anyone? Give me 1 second. Give me 1 second. I'll share my screen. Right. Hi, everyone. Thanks for sorry. So thanks for inviting me to kind of the meetup and the talk. So today I'm going to talk about rapid prototyping with n8n and Qdrant. So let's get started. So what is n8n? So n8n is a visual low code automation, AI automation tool. And in Gist, you just basically drag these nodes and connect them to sort of make these kind of workflows that do amazing things really quickly. n8n has been around since 2019. So in that time, the team have built an incredible amount of integrations. So over 500 plus. Plus, we have thousands of community members contributing their own community nodes. So what you see here, the blocks, you can create your own and use them in n8n. For me, in the last 2 years, the n8n team have done a fantastic job in bringing AI into the platform. So strong foundation in automation, and then kind of worked on fantastic AI sort of nodes and capabilities into the platform since 2021, I think, or 2. Yeah, so fastest way, just very simple. n8n is really the fastest way to build AI automations and agents, in my opinion. A little bit biased because I do use it daily for my work. Right, so that's n8n in a nutshell. So why would you use something like n8n? Typically, when you're doing automations, you're not really building anything for yourself, but rather you're building it for other people. So your teams, the product owners, even the leadership. And you're always going to be asked small favors to kind of build this, build that. Standing up 1 or 2 agents is probably something you can handle. But once you get into the 10s, into the 20s, into the hundreds of requests to build kind of slightly varying different types of agents and automations, it can get pretty overwhelming, I'd say, to kind of not only to code up such automations, but also deployment and then maintaining them afterwards. So yeah, you can imagine, if you were in charge of that, you'd probably go a little bit crazy trying to keep up with all the demands. And just because AI is moving so fast, how would you keep up with those models? How would you keep up with those techniques? That's why I prefer to use n8n, because with n8n, you've got these amazing AI kind of integration nodes is really kind of covering maybe 90% of the use case in kind of the AI workflows, and where you can connect, common data repositories, like your Jira, like your Asana, with communication channels, like your Outlook and Slack. And just knowing that these are kind of built in to the platform, ready to go whenever, gives you a lot of flexibility to cater to those demands and those requests coming from your team, coming from the wider organization. And it then also supports the latest models, so all the major model providers. And you can also use Olama, so you can use local kind of self-hosted models as well. So teams always updating with the latest in sort of AI trends. So you can be confident that when you adopt this platform, you're not going to get left behind, with all the AI developments and stuff. Right. Just going to go very quick technical overview. So n8n there's two kind of flavors of n8n you can use. So one is the community edition. Community edition is something you self-host. So it's self-hostable, keep it within your organization, air gap it for security and data privacy. Or you can use the cloud version, which is managed by the team. Difference being that, when you self-host, you're in charge of what service you put it on, how much resources you give it. Whereas obviously in the cloud, it's all kind of managed for you. It's free to download on Docker, so it's just a Docker image you download, and you can just use it right off the bat. And the community edition, if you're just starting out, I would recommend going for the community edition of n8n, just because it's very hackable. You can bring in other dependencies. So as I mentioned before, community members create their own nodes and they share them on NPM, and you can kind of install these and use on in your instance, or you can create your own. So there is documentation on the official site where you can experiment, and if there isn't a node or a service which is currently supported, you can build your own and go from there. Just a quick architectural overview. So this is n8n sort of like under the hood, kind of how it works. For me, what I love about this is it's really easy to understand how n8n works. Got solid components for persistence, an application layer, and in this particular configuration, n8n comes with a distributed mode called Q mode. And what this means is that as you grow your usage of n8n, n8n grows with you, because you can scale with workers where you delegate work executions to, and you just keep adding more workers. If you need to scale to 100,000 requests a day, you just keep scaling, just adding more and more workers to the pool. It also comes with sort of the editor UI, which is kind of what most people see and think, and regard n8n as, is the infinite canvas where you kind of build your workflows, and the triggers, which kind of triggers. I guess one thing that you might not realize is that n8n can actually work headless, in a headless mode. So you don't really need, you can disable the front end part, so the whole kind of editing, and just run the workflows without that interface. And because of that, you can actually run n8n on one of these. So very low powered machines can also run n8n. It's quite efficient, easy to work with. Again, solid components, just kind of brought together very nicely. n8n does have a learning curve, but I would say it's not sort of a little bit more difficult than Zapier, but obviously nowhere near as difficult as kind of learning to code, all this stuff from scratch, right? In my advice, if you want to really understand n8n, you really just need to understand 4 components, which is templates, which is how we build workflows in n8n, and these are just JSON files. The fantastic thing with them being JSON files is that you can copy and share them very freely, and we have a whole, our community is constantly sharing these templates. You may have seen them in the template gallery that we have on our main site, or just people in forums and other social media just sharing the template files. Credentials are your encrypted secrets for your integrations, and these are kind of encrypted by default. You can use like secret vaults, but that's sort of like you need an enterprise license to kind of use that, but that is also a possibility. Together with the templates and credentials is what then becomes a workflow, right? Kind of an operational workflow, which kind of does, provides value. And once you have workflows, you just run executions of those workflows. So yeah, just sort of executions being the actual jobs that get run. So these jobs can be triggered manually, triggered by other apps, or triggered on a schedule. So like a cron job. So that's really, once you get your head around sort of these components like this, these are really the 4 pillars of what makes n8n tick. So the point of this talk was this basically just going over like how would you rapid prototype, since n8n has all these capabilities with Qdrant. So there are kind of 3 ways in which you would build Qdrant with n8n. So we have the Qdrant vector store node, which is kind of the most common and sort of the first one that the first way that a lot of people encounter Qdrant in n8n. The Qdrant community node, which is quite new, just recently released. And then there's a third option, which I won't go into now, but I'll save it to the end. Those are just for like, if you're a hardcore dev, this is definitely rock your, will be off your street, I guess. So first one, Qdrant vector store node. So this is the most common one, and typically the one that does 90% of kind of what you want to do with Qdrant in n8n in an AI workflow. And you don't need to do anything to install it. It's already in there, kind of as part of the built-in nodes. And this is best for your typical RAG workflow where you're inserting documents and pulling stuff out, searching, simple similarity search with filters, and it's easiest to kind of integrate with AI agents on the platform. But yeah, the vector store node is kind of does most of what you really want to do. And typically this is how you would see it used, a standalone for inserting documents, and as a sub node, sort of attached to the agent as that vector store, that knowledge base. One thing probably just to point out is with n8n, it's very easy to attach kind of re-ranking. So it's kind of a new thing that came out where you can just attach re-rankers to that knowledge base. So when the agent taps into the knowledge base, that re-ranking occurs. So really easy to kind of piece together really kind of useful or effective RAG workflows like that. So that's vector store node. Using just this node, you can build something as simple as this HelloFresh recipe assistant. So this is kind of something I built where I am scraping HelloFresh recipes for the week, and then kind of having that metadata sort of inserting that standalone vector store node, and then using an agent to tap into the documents for recommendations of kind of what I want to eat based on my needs. So very easy to kind of piece this kind of flow together. So that's the first one, Qdrant vector store node. The second one is the Qdrant community node. So this is kind of a recent release. You can now use this Qdrant vector store node in both the community edition and the cloud edition, as we now have kind of verified community nodes on the cloud. And to use it, you just kind of search it in the nodes panel and you install it. So there's a big install button, and you can see next to the node itself. And once you install it, you can just crack on and kind of use it. This node is particularly good for using more of the Qdrant advanced APIs. So Qdrant, what I love about Qdrant the most is that it has these awesome APIs that come with the vector store that does a lot of useful things. But with this node, you can tap into those APIs to kind of manage your collections, build your indexes, but also kind of manage on a more granular level stuff that is kind of outside the kind of RAG kind of workflow. One particular use case I like to use the batch groups API. So having this sort of capability to kind of have results in a grouped sort of result set, which is where sorry. When you have kind of a lot of different documents, it's kind of very useful for that to get the results kind of you want. So you're not having one document kind of dominate the results when you're kind of searching. So really, really cool. With this node, I built a YouTube video transcript, which I found a fantastic use case for the group search API from some kind of use this node for it. But what I did was across the YouTube channel, I'm scraping the transcripts. And then when I want to do a transcript search, obviously, I don't want kind of one video to kind of dominate the results. I kind of want to see if the query is showing results in multiple videos. So that's kind of where I used this particular API. So using that, then I kind of send it to the AI to kind of summarize. So yeah, just kind of a better user experience. An example of kind of how you can use this node in your AI workflows. So that's the Qdrant community node. And finally, the third way we can use the Qdrant in n8n is using the client SDK. Yeah, so you can actually install dependencies. This is community edition, by the way. Kind of just dependencies with n8n. So in this instance, I'm building a custom n8n Docker image, basing it on the latest release of n8n, and I'm installing the Qdrant JS client. Definitely for the hardcore developers, and I guess low-code non-believers. But yeah, with this kind of this flexibility, you're not really going to see in any other low-code platform. You can basically just write code. In n8n, you have the code node, which runs both JavaScript and Python. In this case, obviously, because we have the JavaScript SDK, we can basically just use the SDK as you would in a typical TypeScript environment and use it that way. So yeah, connecting it like that. So if you have for example, this would be good for if you had sort of certain examples in the documentation that you kind of want to test out, you can just copy it like for like into this node and just run it in an n8n workflow. So really, really cool. With something like this, I have built sort of a contextual retrieval kind of system using dense and sparse vectors in n8n. So because you can use code, you're not really limited by the platform, and you can take it as far as you want. Obviously, not recommended because it is a lot of work, but useful for trying stuff out. So this was a really cool exercise in doing that. So yeah. Conclusion. Yeah. So yeah. Finally, yeah. So n8n with Qdrant, super fantastic. A must-have tool if you are building AI automations, not just because of the power that you get with the certain kind of AI nodes and the integrations, but just really fast to build some of your AI ideas, POCs, concepts, really, really cheaply. So you don't need to stand up any code, stand in your repositories, get a deployment going. You can just really build it, just straight into n8n and release them, and just kind of expose them, which kind of just helps you. If you needed to build 20 agents, but in the quarter, this would be fantastic, and then it would be fantastic to kind of give you that flexibility, to do so. And yeah, and once it's not only for demo projects and toy projects. We actually have real enterprise use cases and production these kind of workflows running in production for a lot of large businesses. So n8n, again, with the Q mode, distributed mode, it grows with you, it scales with your usage, and it's, yeah, solid piece of tech that you can use, especially with Qdrant. You can kind of bring that in and definitely make great AI workflows and products from it. Yeah, so that's it. So thank you for listening. If you are listening, I can't actually hear you guys, but yeah, my name is Jim. I am an automation engineer, so I do this for a living. If you want to reach out, talk more about kind of what I do, and yeah, it's a link if you want to get a copy of this deck, either for 3, 2, 1. Finally, I'm just going to run through a quick demo. And I said, did promise I was going to do a live demo today. So this is a very simple recipe agent or recipe RAG agent. I'm just going to zoom in for a bit. And what we have is an ETL pipeline. So this is the pipeline to kind of have documents into the store. So this first bit is me running it to create my collection. And these are the product indexes I'm creating, because I do a sort of facet search later on. Then I'm going to import data. So this is just a recipe JSON. And I can show you here. So it's just a JSON file I pulled off GitHub, and it just gives me all this data, which I'm then splitting into items. So this is kind of like, this kind of looks like. And then with this data, I want to do two things. I want to create vectors which embed the descriptions of the recipes, and then another set of vectors which are embedding the ingredients. So kind of using it as two forms of search. So if I run this guy, I should probably, yeah. This is, I'll just let us finish. Probably on this one. It's still going. Okay, so that's done. So in n8n, how you, so you get a standalone Qdrant vector. This is the Qdrant vector store node, and this is, yeah, the Qdrant collection. But I just wanted to show you guys. So here is where I'm having the description in the data. So this is kind of the context. And then this is where I put the metadata. So in this, I'm putting the name, URL, image, cuisine, and category. And topic. So this is in, so this is the page contents, the payload, I guess. And the metadata is here. So that's kind of where I put in the metadata. So very simple. I don't know if you guys know about this, but n8n, but you can actually drag values over, so you don't need to kind of type it. So. Right, and then I'm gonna let's run. So yeah, so now I'm just going to do the vectors on this guy. Embedding. Yeah, so typically I would just click this button because I'm going to run a demo. I'm kind of clicking them one by one, but you don't have to click them one by one. You can just sort of click it once and it run everything. So that's in this one. The results look more like this. So the payload is the ingredients. So not the description, but the ingredients. So if I wanted to search for recipes by ingredients, this would be the one I would use. Right. So now in my store, I should now have. Yeah. There you go. So this is the collection we just created. With 100 vectors. Yeah, 104 vectors. Points. Sorry. So how do I now use those, right? So here is how you would build sort of a RAG agent in n8n. You would have an AI agent here, which is connected to a chat trigger. And the chat trigger is basically you can now just chat, say hello. Yeah, here you go. So this is very easy to kind of spin up agents in n8n, you just kind of use this AI agent node, which is conveniently in this option. You just click, drag it into the panel. It's kind of how you set it up. But because we want to use the vector store to power this kind of RAG agent, we can create these guys. So here is the Qdrant's vector store subnode, and this is a tool. So it acts as a tool, and for this one, where I'm saying it's search by description, I just added the filter so the topic is always description. And similarly, when I want to search for ingredients, this metadata topic is ingredients. So that's how I'm kind of separating the two, and why I sort of embedded both separately. So how do I now add these vector stores to the agent? And I simply just connect them like this. Right. So now my agent will pick up on these. So if I say, find me some recipes which use lemons. So since the agent has chosen not to use this search, but to search by ingredients. If I look at the logs here, I can see it provided the inputs lemons, and this is what Qdrant returned. And then it was re-ranked by Cohere, re-ranker. And then finally, the output, so my chat again. The output is in the chat. So because we had the images in the metadata, it's also decided to sort of embed the images as well. So yeah, so really low, really didn't have to do a lot of work to kind of put something like this together. And you can imagine if I had to do a lot of these for me using n8n, it wouldn't be, would definitely be no problem. The other thing is that chats can also be made public. So with each chat trigger, you can decide to make it public, which gives you a sort of a front end to that chat. So you can distribute this chat to other people to test out. So like here's, hi, give me some recipes that use lemons. So this is all comes with n8n. So I didn't have to build any of this myself. When you use n8n, you get provided this. So it's really easy to kind of spin up these PLCs to let people try out your RAG agent. Finally, similarly, you can build MCP servers in very much the same way, and that we have a dedicated MCP server trigger. And using this, this is all really you need to spin up your own MCP server. And again, just by attaching the tools here. So all I've done is I just copy pasted this over here. I've now created an MCP server, which I can use with Cloud Desktop. We can use with OpenAI to hit the same kind of Qdrant vector stores. So that's it. Thank you.